Going to solve one of my favorite LeetCode problems, and it's 11th problem saying container was most water. And what we have to do is basically we are given an array of numbers where each number represents the height of the column, and our task is to find the maximum amount of water that can be stored in between these columns. The first solution that comes to my mind is iterating through each column and comparing it with other columns to check for the maximum amount that can be stored. But as this requires two loops, a loop inside loop, it will result in time efficiency of O n squared, which is not efficient at all, and it may fail to tests with larger inputs. So the most preferred and the most easiest way to approach this is to use two pointers, and it's also given in the hint here, which has helped me a lot. Basically, you will set one pointer all the way to the beginning, to the first column, and one all the way to the end. And as you iterate through, you will check the amount of water that can be stored, and you will update the maximum value accordingly by checking. And in each iteration, you will move the pointer which has the shorter column. And as we go through like this, in the end, we will get the solution that we want, and we can submit it successfully. So we can start by defining two pointers. The first one will be 0, as it has to point all the way to the beginning. And the second pointer has to point all the way to the end, which is height dot length minus 1. And it will point all the way to the last item in the array. And let's also define max variable to return it as a result at the end. And while I is not equal to j until the two pointers meet, basically, we're going to determine the amount of water that we can store in between these columns. We can do that by saying container, and the first thing to calculate the amount of water is to find the distance between the columns, and we can do that by subtracting the first pointer from the second one. So it will be j minus I, and we have to multiply it by the shorter value of the column. For example, in the first case, it will be 1 and 7, and it will give 1. And why we need the shorter column? Because we cannot fit water above the minimum column, right? That's why. And we can get this by using math.minimum function, and we will pass the first value, which is height I and height j. Okay, and we will have to update the maximum variable to math.maximum, and we'll pass the current maximum value and the value that we just checked now. So what this basically does is, as we iterate through, it will check the maximum amount that we have checked up to this point, and it will compare it with the current measurement that we did, and it will update it accordingly. Next, we want to move the pointers, and we will check for the shorter column. We can do that by passing height I. If height I, the first pointer, is less the first column, if the first column is less than the second one, we will move it to the right by incrementing it by 1. Otherwise, we will, oh sorry, I have to move the pointer, not the value. Otherwise, we will move the last pointer to the left by decrementing it by 1. And at the end, we can return max as a result, and it will give us the solution that we want. It says the answer is wrong. Why? Let's try to take this in parentheses. And it works. So we had to take this into parentheses to make sure that it's being multiplied by the distance in between. So let's try to submit it just to make sure. And it's accepted. So it beats 52% of the solutions out there. When I had submitted before, it was 96%, but I'm not sure why it's not like that now, although the logic is the same. Okay, I think you got the solution, and I hope you enjoyed the video, and hope to see you in the next videos. Peace.